We'll attack this first integral now. So the first thing we'll see is that I can make it a little bit easier to follow. Since we're taking the derivative with respect to c first, right? Well, there's an a and there's a 2. The 2 can be taken all the way out of the integral by the constant rule, and the a can be taken back to the area where it will be integrated, where we will integrate over a. So let's make that a little bit easier to make this integral a little bit easier to follow. This integral from 1/4. Whoops! I said we're going to take the 2 out, didn't I? This is 2 integral from 1/4 to 1. We're taking that square root of a over here. The integral from 1/4a to 1 of, I'm going to write c to the 1/2 just to make it a little bit easier to use the power rule. Probably do that with the a also, but when we get there. And this is derivative. So we're going to take this first derivative, and let's not skip any steps here because this is just really a beautiful integral to take. There's going to be a lot of algebra, so I'll rewrite this as a to the 1/2. So now we're just going to do what's in. Let me put the dA out here. So we're just working on what's in here. Well, this is just a straightforward power rule. Increase the power by 1 and divide by the new power. And I'm going to do, so they increase the power by 1, and we have c to the 3/2. Okay, I'll just do this. C to the 3/2. Divide by the new power. Dividing by 3/2 is equivalent to multiplying by 2/3. And we're evaluating this at 1 and subtract evaluation at 1/4a. So at this point, we see this constant 2/3 that can also be moved to the front of the integral. So we have a 4/3 out front here now. That's just taking this 2/3 times 2 is 4/3, and we're still waiting to integrate, patiently waiting to integrate with respect to a. We have a to the 1/2. So let's do this. And let's keep our dA out here just to be mathematically precise. We took this 2/3 out, so we're evaluating at 1, and so we have 1 c to the 3/2. Well, at evaluated c equals 1, it's just 1, and then we subtract off evaluation of c to the 3/2 at 1/4a. Now, let me just write that over here, 1/4a to the 3/2. Now we're going to use a lot of what we know about exponents and stuff. So this is 1/4 to the 3/2 times a to the negative 3/2. Okay, so that's I just did one quick step there. 1/4 to the 3/2. Well, that's the square root of 1/4 raised to the 3rd power. The square root of 1/4 is 1/2. Raised to the 3rd is 1/8. So we have 1/8 a to the negative 3/2. So we have 1/8 a to the negative 3/2. Okay, we're almost there. We're not going to use the product rule on. I'm sorry. We're going to distribute this a to the 1/2 over each one of these terms. So we have. Let me get rid of this so that we have some room to work with. So this equals 4/3 integral 1/4 to 1. Keep our dA out here. This distributing this a to the 1/2 over both these terms. We have a to the 1/2 minus. So that's that first term, and then we have minus 1/8 a. Well, what's 1/2 plus a negative 3/2? So that's negative 1. Negative 1. Ooh, can smell the natural log, can't we? So what's next here? Let's go up here. We still have this 4/3 out front. Maybe we didn't magically disappear it. Now we're just going to use the power rule and then natural log on this stuff. We have the first one is a to the 3/2 divided by the new power is multiplied by 2/3 minus 1/8. Well, the integral of a to the -1 is natural log of a, and we're going to evaluate that at 1 and subtract evaluation at 1/4. All right, we're almost there, and we have some of this was, well, you're going to see some terms canceling and getting very easy. So let's first evaluate at 1. We have, we're taking 1 to the 3/2, well that's just 1 times 2/3, so we have 2/3. And looking ahead, let's just see, we take the natural log of 1, well that's just 0, so we get minus 0, and then we're subtracting off evaluation at 1/4. Similarly to what we just said before about this 3/2, when we put in 1/4, let's just do that 1/4 to the 3/2 power, that's the square root of a quarter, which is a half, to the third, which is 1/8, so we have 1/8 right there. Don't forget we have this 2/3 term times, well, let me write it in order. 2/3 times 1/8, and we have minus 1/8 times the natural log of 1/4. Boom. Oh, and that was this right here is all evaluation of the expression at 1/4. Yahoo! We're almost there. 4/3 times. Well, we have. Let's just go ahead and do this. We have 2/3 of 1. Well, that's 0. I'm going to kind of ignore that for a second. But we have 2/3 of 1, and we're subtracting 2/3 times 1/8. So we have this. You can think of this 1 as 8/8, and we're subtracting off 2/3 of 1/8. So we're left with 2/3 7/8. That's just taking, just being slick about taking this term, and then we're going to add. What are we adding here? Because it's minus a negative 1/8. We're adding 1/8 natural log of a quarter. And let's do some, remember this is all being multiplied by 4/3. So I'm going to keep the 4/3 out there. And we have 2/3 times 7/8. Well, this 2 and the 8 cancel, leave 4. And we have 7/12. 7/12 plus 1/8 natural log of a quarter. And at this point, we can go to our calculators to come up with the natural log of a quarter. And natural log of a quarter is negative 1.386 divided by 8 is negative 0.173. So plus negative 0.173, 7/12 times 4/3, and this is going to equal, let's see, I'm going to add 7/12 back. Boom. Times 4/3, 0.547. So this whole thing is going to be 0.547. So I don't know, I hope I don't have ran out of time. 0.547 is let's say 0.547. So we have this integral, subtract that integral, we have 0.144, 0.144, and that is the volume of the cap. And I'm going to finish